Alright, by request we've got this video about Bayes' theorem. I'm going to mention that when working with IB, it's oftentimes important to learn the formulas, even if the formulas are not practically useful. So as I instructed you, when working with Bayes' theorem, we should use the common sense that comes with a tree diagram or a conditional probability table instead of trying to understand that silly theorem. However, the theorem is in our formula packet, and there might be an instance where we would need it. That might be the emergence, or that might emerge as we explore this particular exercise. To begin with, I want to start doing a tree diagram because that's what makes most sense to me. But I run into a roadblock here. Starting with the fact that we know that the probability of A is 0.3, the converse then should be 0.7. That's no problem. The other given information is the probability of B given not A is 0.4, so we can ascertain 0.4 and the 0.6 for these two branches. However, as implied by the question, the probability of B given that A, we don't know that yet. And if we don't know that, then we can't infer probability of not B given that A, which gives us a little bit of a problem. Our tree diagram falls apart. So, we have to look at some other information that's given, which is the probability of A given that B. Once again, though, it's problematic because I don't know anything about the probability of B either. So, in a moment of desperation, I go to my formulas packet and I look at Bayes' theorem and hope that maybe that'll come out for us. So, I know I'm trying to find the probability of B given that A, so that's what I'm looking for. So I try the formula and see if it helps me out. In the process, I observe, first of all, that the formula makes sense, but second of all, that the only known values are based on the given information are the probability of A given that B. They told us that was 3/17, but I don't know the probability of B, and I don't know the probability of not B, or any of the other unknowns. There's way too many unknowns here. The alternative is look at the other form of Bayes' theorem, that is, reverse the variables. What about the probability of A given that B has occurred? We write the formula out, and so doing, make this quick discovery. We know the probability of A is 0.3, that's given. The probability of not A is going to be 0.7 then, by converse. The probability of A given B was a given information at 3/17. And the probability of B given not A was given at 0.4. Which basically means the only unknown left is the one we were seeking, which is the probability of B given that A. So this entire problem of probabilities basically boils down to, do you know which formula to use, and can you do algebra 2? Variables, the top and bottom, I'm going to treat this like a proportion and cross multiply. Collect like terms after I distribute the 3 and the 17. And then divide. The probability of B given that A is 0.2. Now, we don't want to abandon this tree diagram since we went through the trouble of using it in our exploration. So what we can do is use it as a built-in checking mechanism to make sure all my calculations are copacetic. See, if I have 20% chance of B given that A, it means I have an 80% chance of not B given that A, and these make up probabilities of B occurring given that A's occurred. Likewise, we could have B occurring or not occurring given that A has not occurred. Add all these together, you should get 100%, which you do. So, success. Thanks for watching.